All right, this lesson is going to be talking about inverse trig values visually in degrees still. And so I thought it would be easier for me to just make a video. You don't have to take notes over this. You'll get it, I'm sure, pretty easily. It says draw a horizontal, vertical, or diagonal line to represent the equation sine of some theta angle equals negative 0.97. And then use that to help you solve the equation from 0 to 360 degrees. Make sure your answer is in the nearest tenth. So what I want you to think about is if I have sine of an angle, sine is the y values. So think about any line that's y equals something. It's going to be a horizontal line. I used to use this mnemonic like HOI for horizontal. And so I can take this now and slide it up and down. See how the yellow points stay on the outside perimeter of the circle as I slide? Well, I'm wanting to put it at where sine values would be negative 0.97. And we talked about how on our unit circle, sine and cosine always stay between negative 1 and 1. So negative 0.97 would be past negative 8/10. That would be negative 9/10. That's negative 1. Negative 0.97 or 97 hundredths would be somewhere down there. And so then what I want you to imagine is taking an angle in standard position where the first ray is here, and it opens up to where this yellow point would be. And so what we're really trying to figure out is what is this angle to here in quadrant 3, same thing with what is this angle here in quadrant 4. Okay, so what I need to do is find the reference angle, which I know I do by inversing sine, putting in the positive 0.97 just to get the reference angle, and that would be 75.9 degrees. And so remember in quadrant 3, I take 180 plus. So this would be at 225.9. And then I have this one, I would do 360 minus 75.9. And those would be my answers. Okay, next one is same thing with cosine. Cosine of an angle, remember cosines are the x values, so any x equals a number cuts through the x-axis, so that'll be a vertical line. I need to find it where it would be 0.54. So I'm going to drag this, it would be positive. There's 0.5, halfway between 0.4 and 6. 5.4 would be almost halfway through that box, somewhere like that. So the angles we're finding are here in quadrant 1 and in quadrant 4. So I would do second cosine 0.54. My reference angle is 57.3, which is what this angle is. So 57.3. Then to find the other one here, I would do 360 minus. It'd be 302.7. And one more, that's a tangent. So tangent is y over x, like slope. Remember, change in x over change in y is slope. So you will select a diagonal line, and this helps you remember that tangents are the same values diagonally. So it's positive in quadrants 1 and 3. It's negative in quadrants 2 and 4. See the slope changing? Okay, and so they want the change in y or the change of x or the slope to be negative 2.4. So you'll have to play with this until you get it, and I'm trying to make it steeper, right? The bigger the number slope means the steeper the line. Right there. So my slope is 2.4. So I'm trying to find an angle here in quadrant 2 and an angle in quadrant 4. You would do second tangent, 2.4, and so my reference angle is 67.3. So I would do 180 minus 67.3. This would be 112.7 degrees, and then I would do 360 minus 67.3 and get 292.7 would be this one. I won't type those in, but kind of fun to see where the angles are at visually on the unit circle.